Hello everyone, welcome to the new session on projection of solids. Now we continue with projection of pyramids. Now we'll touch upon problem 3, and this problem 3 is similar to the problem 2 what we had done in the session 1, but there will be a small change in the step 3, and that will be explained in this problem clearly. Now as you see here, it is a square pyramid of sides 80 and 150 like the previous problem, which is resting on triangular surface on HP, and for which I have the top view here. In the previous problem, the top view of the axis itself was inclined at some degrees to VP. But now in this problem, what is being given is the true length of the axis should be inclined at 45 degrees to VP. But the problem here is over 1, this axis is not in true length. But the true length of the axis should be inclined at 45 degrees to VP. Hence we do a small construction here. Now what we do here is we take the true length, we take the true length and cut the true length equal to 150. If you have taken 1:2 scale, it is 75 mm cut here, and we get the locus. And this is done at 45 degrees, which they are given in the problem. The true axis is inclined at 45 degrees means it is the true length of the axis which is inclined at 45 degrees to AP. But since this is not in true length, this procedure is done, which is called the beta construction. Now what you do is, we take the top view length here over 1. This top view length is cut here now. Now you get beta. Now the top view, second stage top view should be tilted at beta, that is at 48 degrees. That is what we do here now. Now the third stage top view, the top view of the axis is inclined at beta, so that the true length of the axis is inclined at 45 degrees to VP, and this is the construction to be adopted, which has to be taken care of carefully. And now once you have this, the procedure remains same. You take it to the front view and get all the points from the top view. This is O dash, A and B, A dash, B dash will be here, C dash, D dash will be here. And as I told you in the session 1, first step is to complete the outer boundary of these points. This outer boundary of these points, once we complete, it is already 3 edges here, it's a triangular surface, 4, 5, 6 already over. You have to complete 2 more edges. Now as you see here, that is the step 1 is completed. Once you go to the step 2, we compare apex with the base. Since base is nearer, since the observer is looking from here, base is nearer, we darken the base. In that way, we have completed 7 edges. Lastly, there is one edge which is remaining, O dash, A dash. For an observer who is looking from this direction, from here, AO is the back edge, which cannot be seen by the observer, hence we make it invisible. In that way, we are able to complete all the 8 edges. Finally, we will see that the axis is also completed this way. That is, from O, we take it to this O1 dash, and O dash, O1 dash, it should be a light line. It's an imaginary line. It's an axis of symmetry line. This axis is also completed. This is the problem number 3. Now the problem 4 says this: a square pyramid of base sides 35 and height 60 has one of its base corners on HP with its axis inclined at 40 degrees to HP, and the top of the axis is inclined at 45 degrees to VP. We have to draw the projections in this position when base is nearer to the observer. And what you should observe here is, in the previous problems and all that, we used to rest the square pyramid on edge on HP. Now it is corner on HP. That is why we have to change the position of the square pyramid this way. Write the square pyramid in this way. Write the square pyramid in this way. That is, once you do the square pyramid in this way, draw AB, BC, CD and DA. Then you draw OA, OB, OC and OD. You have 8 edges here in the top view. Then get the front view also. The front view, the height is 60. You take the height as 60. Okay. Once you take the height as 60, now you count the number of edges again. Here you have the 4 edges. This is a slant edge. This also slant edge. And in this, there are 2 slant edges, one behind the other. One front edge is OB and the back edge is OD. And this is darkened, this is darkened, this is darkened. Behind this is an imaginary axis. Axis has been shown as O dash, O dash. Okay, totally 4, 5, 6 plus 2, 8 edges are there. Now, what you do is, if you tilt it, this front view and this front view remains same as it is more parallel to VP. And as you see here, when it is tilted right, it is resting on corner C and HP. When it is resting on corner C and HP, okay, and we have adjusted in such a way that as per the problem, the axis is inclined at 40 degrees to HP. You have tilted in such a way that axis is inclined at 40 degrees or base is inclined at 50 degrees. In this position, when you are looking from the top, how it appears in the top view has to be written. For this, the procedure remains same. Get all the points from the other view. Get all the points from the other view and join the outer boundary of these points. This serves as the first step. For all problems under projection of solids, we are doing more or less in the same way. Get all the points and join the outer boundary of these points by dark lines. Okay, that is 0.5 mm thickness lines. In that way, first step is completed. Now you are looking from here. Compare apex with the base. As you are looking from here, apex is nearer to the observer than the base. Immediately, remaining edges of the base make it invisible. In that way, DC and CB make it invisible. Totally now, 6 edges are completed. Now, you are left with 2 more edges. Second step is over. Third step, all nearer edges are darkened and faraway edges are made dark dotted. When you are looking from the top, OA is the nearer edge. Hence we darken OA. And OC is faraway edge. When you are looking from the top, the back edge OC cannot be seen, but OA can be seen. That is why when we darken OA, but actually OC is invisible, but that is merged with OA. Hence we cannot show OC as dotted edge because we always prefer visible edge over invisible edge. Now in the third stage, what has been happening here is the top view of the axis is inclined at 45 degrees to VP. That is what is the problem. Now you move, copy and rotate it by 45 degree so that the axis OO1 is inclined at 45 degrees to VP. Now once you do this, you take the projectors to the front, take all the points as you see here. From here it is O, on this A, on this it is B and D, on this it is C. And the first step says, once you get the points, join the outer boundary of these points. Join the outer boundary of these points using dark lines only. Now I have just enlarged the thing. Once you join the outer boundary of the points, you will get like this. I have just zoomed the area. Now since base is nearer, you darken the base. Now as you see, A dash, B dash and B dash, C dash and C dash, D dash and D dash, A dash forms the base. The base is darkened. Now as you see here, you are left with only OB, O dash, B dash and O dash, D dash. And the third step, all nearer edges are darkened in the view and faraway edges are made dark dotted. O dash, B dash, we darken it. O dash, D dash, we make it invisible because O dash, B dash is darkened just because it is nearer to the observer. and O dash D dash we make it dark dotted because it is far away from the observer. And finally we show the axis here as O dash O dash. And this is the next problem what we have completed. Next, problem 5 says the square pyramid of base size 35 and height 60 has one of its base corners on HP with its axis inclined at 40 degrees to HP and inclined at 30 degrees to VP. Draw projections of this pyramid. Draw projections of this square pyramid in this position when base is nearer to the observer. Now, as you see here, this problem is similar to the previous problem, except for previous problem. In the previous problem, top view of the axis was inclined at some degrees to VP. But here in this problem, they have clearly said axis is inclined at 40 degrees to HP and 30 degrees to VP means the true length of the axis should be inclined at 30 degrees to VP. But what you have in the second stage top view here is not the true length of the axis. Hence we undergo a beta construction which has to be shown clearly. That means what you do is draw a line at 30 degree, cut O1 OX which is the true length of the axis, that is equal to 60 mm. That means O1 OX you cut 60 mm. Once you cut 60 mm, you have the top view of the axis which is not in the true length. This length you take and cut it here, O1O. That gives beta. Now what I suggest is this O1 should be inclined at beta to XY line, that is VP. This has been shown here. Now as you see here, this O1 is inclined at beta and this is the construction to be shown where the true length of the axis is inclined at 30 degrees so that the apparent length, that is the top view of the axis is inclined at beta. This constructions once you do, the procedure remains same. You take the procedure, you take the points to the front view, and as you see here you have O dash, here on this A dash, on this B and D, on this C, all you get the points. Once you get the points, step 1, join the outer boundary of these points by dark lines, that is using 0.5 mm thickness lines, directly darken it. Then you compare base with the apex as usual. Once you compare apex with the base, you clearly see when you are looking from here, base is nearer, immediately we darken the base. Now once you darken the base, step 2 is completed. Now count the number of edges, 4 plus 2, 6 over. Then you are left with only 2 edges, OB and OD. OB, if you see here, when the observer is looking from here, B is the nearest corner and OB is the nearest edge, hence it is darkened in the view. And there is one more edge to be drawn, that is O dash D dash, that is OD, which is far away edge. When you are looking from here, OD cannot be seen by the observer, hence it is made invisible. And finally, the axis is shown as this. This completes the problem number 5.